Hi everyone, welcome to the new video. In today's video, we are going to start with a very interesting topic, and the name of the topic is functions. Okay, so I hope whatever we have studied in relation, you are practicing the things time and again so that you have a better grasp on the relation. If you understand relation well, then you won't find function hard, okay? Because these are interrelated, okay? So let's start with functions, okay? Now, what are functions? Okay, so functions, they are just the extension of relations. Okay, now if I have to define functions in very simple words, because you have just finished a relation, so I will say that some, okay, some relations are known as functions. Okay, so here, first of all, I will write here, okay, some relations are known as functions. Okay, now this is ambiguous and vague definition. Why? Because it says some relations are functions, whereas some are not. So it means that there are some conditions that are put on relations in order for it to behave as a function. Understand? I am repeating again. This statement, some relations are known as functions, it simply says that there are some relations, there are some conditions put on relations in order for that relation to be a function. If the relation satisfies that condition, then we call it a function. If relation does not satisfy that condition, then it is not a function. Okay, so we will try to analyze those conditions which is required in order for relation to be a function. Okay, so let's say that here I have set A, okay, and here I have set B. Okay, so in set A, I have elements 1, 2, 3. Okay, and in set B, here I have elements A, B, C. Okay, now there is a relation defined from A to B. This is a relation that is defined from A to B. Okay, and we know that this means that there is a relation defined from A to B. Okay, now the relation is defined in such a way that this element A is mapped to 1, 2 is mapped to B, and 3 is mapped to C. Okay, so we have two sets, and the relation is defined from set A to set B. Now, in order for this relation, to behave as a function, okay, in order for this relation to behave as a function. Now here, this means that this relation R, it is said to be the function f. Okay, it is said to be the function f, and f is a function defined from A to B. Okay, so basically here I just wanted to show you that what are those conditions that are required for this relation to be a function. Okay, so in order for this relation to be a function, it must satisfy this must satisfy must satisfy two conditions. Okay, two conditions. Condition number one says that every element in set A must have an image in set B. Okay, I repeat again. Every element in set A must have an image in B. Okay, so first thing is that every element in set A have an image in B. If you look at each element of set A, you can see that 1 is mapped to A, so A is the image of 1, and 2 is mapped to B, so B is image of 2, and 3 is mapped to C, means that C is image of 3. Okay, so every element of set A must have an image in set B. Okay, so this is the first condition. If there is any element in set A which is not mapped to any element in set B, then we will say that it is not a function. Okay, it can be relation, but it will not be function, because the main condition is that every element must have an image in set B. Okay, and condition number 2 is the mapping must be unique. What does it mean? The mapping must be unique. It means that for each input, now see here, for each element of set A, okay, for each element of set A, you must have a unique image in B. What does it mean? It means that every element in set A must have a single mapping. Okay, see here, element 1, it has only one mapping, it has only one image, that is A. It does not have two images. Okay, so the mapping must be unique. Understand? Means that each element in set A must have a unique image. Here the image of 1 is A, here image of 2 is B, here image of 3 is C. So all these images, all these mappings are unique. Okay, if the relation satisfies these two conditions, then we will say that relation is a function. I hope you understand it. Okay, let's take some more examples on it. Here, I have set A, set B. Here, element 1, 2, 3. Here, A, B, C. Okay, here, 1 is mapped to A. This is function f defined. Okay, here I have 2 mapped to A. Here I have 3 mapped to A. Okay, now take more cases. Here I have A, I have here B. Okay, this is a relation. Okay, this is number 1, this is number 2. Here 1, 2, 3. Here A, B, C. Here 3 is mapped to C, 2 is mapped to C, and 1 is mapped to A. Then we have other case where here A, here B, here 1, 2, 3, A, B, C. Here A is mapped to, here A is mapped to 1, and here, sorry, 1 is mapped to A, 1 is mapped to B, 2 is mapped to C. Okay, then we have number 4, 1, 2, 3. Here A, B, C. Okay, here 1 is mapped to A, 2 is mapped to B, right? And 2 is mapped to C. Okay, now I have 4 questions, 1, 2, 3, 4. Okay, now you have to find out which of the given relations are functions. Okay, this is a relation defined, relation defined, relation defined. Okay, so we will just look for 2 conditions. First condition is that every element in set A must have an image in set B, right? And the second condition is that for every element in set A, there must be a unique image in set B, or I would say the mapping must be unique. Okay, so the image must be unique. Understand? So let's start with number 1. Okay, so if you look at number 1, look at all the elements. 1 is mapped to A. Is image unique? Yes, this image A is unique for 1. Okay, now look at element 2. It is linked to, it is related to A. Is image unique? Yes, it is unique. 3 is also related to A. Is image unique? Yes, it is unique. So this is a function. Okay, now image unique. Now some of you may get confused, like here they are representing the same image. Okay, what I meant from the unique image, what I mean is that the elements in set A, okay, all these elements are called inputs. Okay, all these elements are called inputs. The set of elements in A are inputs, and the set of elements in B, or the set of images, is known as outputs. Okay, output. Okay, the set of images represents the output. So unique mapping means that for one input you must have one output. For example, if this is a function f, okay, if this is a function f that goes from A to B, then when you give this function any input, it must give you one output in return. For example, if you give it input 1, then it will process it and gives you output A. It cannot give you 2 outputs. If it gives you 2 outputs, then it is not a function. As simple as that. Now see here, your input is 1 and your output is 1, 2. It is not giving you 2 outputs. Your input is 1 and your output is A, right? Again, your input is 2 and how many outputs are there? Only 1. Okay, your input is 3, 1 input, and how many outputs do you get? Only 1. So this is a function. So this is a function. I hope you understand it. Go to question number 2. Now look at all the elements. Are all elements in set A related to the elements in set B? Yes, they are. Now let's see. Look at the unique mapping. So one input and how many outputs? 1. This is fine. One input, how many output? 1. Fine. One input and how many output? 1. Fine. So this is also a function. Okay, now go to number 3. Are all elements related to the images in set B? Now see here, 3 is not linked or related to any of, or 3 does not have any image in B, so it means this is not a function. Okay, now go to number 4. Look at if every element in set A has an image in B. 1, yes. 2, yes. 3, no. And here also, if, because the image must be unique. But see here, for this element 2, it has 2 images. For 1 input, you are getting 2 outputs, means that it is not a function. Understand? So any relation that satisfies these 2 conditions is said to be a function. What are these 2 conditions? Every element in set A must have an image in set B. Condition number 2, the mapping must be unique, means that the image must be unique. For one input, you must get one output. What are inputs? Inputs are the set of elements in set A, right? And what are outputs? Outputs are the set of images. Okay, so as simple as that. Okay, now here we will talk about few more things. We will talk about few more things. And what are those things? First thing here is a few terms that you must know. Okay, so the first term that you must know is inputs. Okay, inputs. Inputs means the set of elements in set A. Okay, which is here 1, 2, 3. Okay, 1, 2, 3. Then output, right? Output means your set of images. Set of images in set B. Okay, set of images in set B. Now, inputs are also known as set of pre-images in set A. Why? If these are the images, then for every image you have a pre-image in set A. So here I can also say that inputs are also set of pre-images. Then input, output, then we have domain. Okay, now what is domain? Okay, what is domain? Domain of function, first of all, it is represented by df. Okay, and domain is the set of pre-images, means set of all the elements that are in set A. Okay, so it is set of pre-images or set of inputs. Okay, same set of inputs. Okay, so here your domain, it's going to be 1, 2, 3. Understand? So here your domain of a function, it is always, okay, it is always going to be your whole set A, right? So the domain of your function, it is going to be the whole set A. It is not possible that if some element in set A is missing, okay, in this domain. Why? Because we know every element must have an image. So you have to include this whole set B. Understand? So here, this is your whole set A. Okay, whole set A. Now come to your range. Okay, come to the range. What is range? Range is represented by range RF. Okay, and range is the set of images. Here, first of all, set of images. Okay, set of images, and here your range is A, B, C. Okay, but if this is the case, okay, now tell me if this is the case. This is your set A, this is your set B. Okay, here 1, 2, 3, and here A, B, C. And here this is R. Okay, sorry, this is yes, this is your function f. So here 1 is related to A, 2 is a link to A, 3 is linked to A. Now 1 has only one output, 2 has only one output, 3 has only one output. So of course it's a function. Okay, but in this case your range Rf, it's going to be just one element, which is A, because it contains the set of images, and we have only one element in we have one element that represents the image. Okay, here we have three elements in set B that represents the image. So here, that's why the range is element A, element B, element C. But here in this case, range would be just one element, which is A. I hope you understand my point. Then we have codomain. Okay, we have codomain. I think this is not visible. So, okay, we can write here codomain. Okay, codomain. Codomain, it's represented by CODF. Okay, codomain, and codomain is the entire set B. Okay, this is going to be your entire set B. Okay, now if you see here, in this case, if I have to define codomain, okay, of this function, it's going to be A, B, C, because it contains set of all the elements in set B. Okay, it is the set of all the elements in B. Okay, so it is set of elements in B. I hope you understand it. Okay, so this is about the codomain. Okay, now just remember one thing: codomain, it is always given by the person who will set the question. Okay, sometimes you have to you will come across the question where you have to find the domain and you have to find the range, but you cannot find the codomain because this has to be set by the person who is asking you to solve the question. You need to ask him, give me the codomain. Understand? All right. Now there are a few more things that you need to understand. This is a function f which is defined from set A to set B. Okay, and A represents what? A represents the set of pre-images, which means input, right? If I am writing this, f is a function defined from set A to set B. Now, what is A? Set A, this means set A, and set A contains the pre-images or inputs, right? And what is this set B? It contains the images, set of images. So here it means the output. Okay, so function, basically, what does it do? It's like a machine that takes input and processes the output. It is a machine that takes the input, processes it, and gives us the output. Let's say that this is a machine. This is a machine. Okay, and here it takes the input and it processes the output. What is the use of function? Function simplifies the operation. Function simplifies the calculations. Function simplifies math. Okay, what is the purpose of this machine? Machine simplifies the work. Understand? So we represents inputs by input by x, and we represent output by y. Okay, so that's why we say that fx is equal to y. Okay, what does it mean? It means that here my function is a machine that will take x input, processes it, and gives y output. Understand? So here, if you look at this fx equal to y, or fx to y, f is a function defined from x to y. What does it mean? It means that it will take input x. So x is going to be your independent variable, and y is going to be the dependent variable. I hope you know this. Okay. What are x and y in algebra? Okay, these are abstract symbols. Okay, abstract symbols means that they can take any values. Understand? So these are variables, means the values can change. So if f is a function defined from x to y, means that it will take x input, processes it, and gives y output, means that x is independent. X is not depending on something, but y is depending on x. Okay, what does it mean? Your output depends on your input. Your input does not depend on the output, because your output is decided by what input you are giving to the machine. Understand? I hope you get it. Okay, now let's do some questions on this. Okay, so you have to, okay, I also want to show you a few main key difference between the relation and function. Okay, relations and functions. Now see here, here I am writing relation and here functions. Okay, now in functions you can see here that here I have elements 1 2 3 a b c. This is a, this is b, so it's going to be, this is going to be what type of mapping? 1 2 1. Okay, and the other case it could be a and here b, here 1 2 3, here a b c, and here could be many to 1, right? Many to 1, and it can be to a and this and many to 1. Okay, but for relations here it could be 1 2 3, 1 2 3, and it could be one to many. Right, and here okay, so this is your 1 to many, and then we have many to many. Okay, 1 2 3 a b c, many to many. Many to many. One to many. Yes. Is it possible? Many to many. Right? This is many to many. Okay, now see here. Now, what relation is? Relationship relation means that here relationship. Okay, it is relationship between your two values. Okay, so now whenever we have defined relations in the past, or what we did, we basically defined relationships between two values. Okay, we said that how the value in set A is related to set B, right? So for example, here it says one to many, means that one element in set A is related to many values in set B. It is a relation, it is not a function. Why? See here, your element 1, it is giving two outputs, 1 and 2. which means that it is not a relation because the images must be unique. Understand? Same here, many to many. Many elements in set A are related to many values in set B. See here, 3 is related to B and C. What, right? So this is also not a function. Why? Because it must have one unique image. Understand? Then 1 to 1. Now, what is function? Now, if you look at function, what are functions? Function basically is a relation. Now, functions are the relations where one input gives one output. Okay, so here, if you look at each element in set A, it has one output. Okay, these are inputs. For one input, you have one output. Go to next. For one input, you have one output. For one input, you have one output. For one input, you have one output. And every element in set A has an image in set B. So function means that for each input, you have one output. Relation simply means the relationship between two values. Okay, I hope you understand it. Okay, so this is all about this, and now we will see some equations. Now, what are the equations? Okay, find out which of the following are functions. First is x plus 2. Next is here y equal to x plus 2. Here y equal to 2 minus x. Here y equal to 2xy, sorry, 2x, and here y equal to x square, right? And number 5, y equal to x square minus 4. Okay, so you have to find out which of the following are functions. Now, let me tell you something. When you come across any equation that is written in x and y, all equations, okay, see here, all equations are relations. Okay, so always remember, all equations are relations. Any equation that you see or you come across, it is a relation, but not all equations are functions. Okay, now let's come to y equal to, first is y equal to x plus 2. Okay, x represent input, y represent output. Okay, this is A input, this is B output. Okay, now if you put here, if you give x any value, for example, if x is 0, then your y is going to be 2. If your x is 1, y 3. If your x is 2, y 4. Okay, so means that for each input you have one output. You can give any input here, any input. Okay, this input, it can be any real number, right? So because this x is a variable, so it can take any real value, right? And it will give you any real value. Okay, so for each input you will get one output. So that's why this is a function. So this, I would say, it's a function. I hope you understand it. All right, now go to next. Number 2 is y equal to 2 minus x. Again, make a set. Okay, this is set A, this is set B, right? Here, you can take any value, x0, right? Y is going to be 2. x1, y is going to be 1. x minus 1, y is going to be 3. So x can take positive value, it can take 0, it can take negative values, and it will, for each value, you will get one output. See here. So it means that all the elements are going to be related and the images are unique, which means that this is a function. Now go to number 3. Number 3, it is y equal to 2x. Right? Y equal to 2x again. Set A, B. Okay? Give x any value. Okay? x0, y is going to be 0. x1, y2, x minus 1, y minus 2. Okay, so the images are unique. For any real value, you will get only one real value. Okay, which means that it is a function. Now go to next, number 4. Y is equal to x square. Okay, now here you have a problem. Okay, here make a set A, here set B. Okay, now here put any value. Let's say that your x is 4. Okay, if your x is 4, okay, what's going to be the value of y? If your x is 4, y, sorry, if your y is 4, okay, if your y is 4, then what's going to be the, if your x is, see here, if your x is 4, y is going to be 16. Okay, but if your y is 16, for y 16, you it must be here, y square equal to x, y square equal to x, and here y square equal to x minus 4, right? So if you give here x 4, then y, it's going to have two values. Now see here, y square is equal to 4, so y is going to be, which is going to be plus minus 2. So it's going to be plus 2 minus 2. Now how many values? Two values, right? So you have elements, you are going to have the elements where for one input you are going to have two outputs, right? So which means that it is not a valid function. This is not, sorry, this is not. Okay, so this is not a function. Now come to number 5. Number 5 says that y square equal to x minus 4, right? And here again, A, B. So give, here put x, right? Now, if you put x, of course, sorry, put here 4, because we cannot define the root for the negative value. So if you put here 0, y, it's going to have two values, plus 2 minus 2. Why? Because y square equal to 4. Y is going to be plus 2 minus 2. So again, the same problem, that for one input, you are going to have two outputs. So I have just taken the random examples, okay? So it's not going to be the function. I have just taken the random examples, okay? So this is just to show you that what you need to check, okay? These examples are there just to figure you out how to look for the function, okay? Check the input and check for that input how many outputs are you getting, okay? Now, the next thing that here I want to discuss here is that you can even, okay, you can, if someone gives you a graph and tells you that if you tell whether this graph is a function or not, then yes, it's possible. Okay. For example, you have to find out which of the following are functions: number 1, number 2, number 3, number 4. Okay. Now, here, this is y equal to x plus 2. Here, it's going to be y x square plus y square, it's equal to 25. Here, you can take y equal to x cube, right? Y equal to x cube. And here you can take y equal to x square, right? So now all these four equations, they represent curves, graphs. Okay, for example, y equal to x plus 2, this is number 1. Okay, so y equal to x plus 2 means positive slope x plus 2. So it's going to be, this is 2, so it's going to be it's going to pass from here. This is y equal to x plus 2. This is number 2. Number 2 is x square plus y square equal to 25. So this is a xy axis. This is a circle, and here radius 5. Okay, this is 0, 0. Next is your x cube. So it's going to be the cubic curve. Cubic curves, it's going to be something like right, y equal to x cube. And number 4, this is number 3. Number 4, y equal to x square. So it's going to be something like this. Okay, so it's going to be passed through 0, 0. Okay, just the rough idea. Okay, now if you are given with the curves and someone asks you whether these curves are functions or not, so now first thing you need to understand here is that all graphs, curves are relations. Okay, they all are relations, but not all graph and curves, not all relations are functions. So that's why not all graphs and curves are functions too. So here, to test whether a given graph is a function or not, you have to perform one test, and the name of that test is your vertical line test. Okay, vertical line test. What does it mean, vertical line test? It simply means that just draw a vertical line anywhere on the graph, okay, and try to figure out how many times that vertical line is going to pass through the curve. Okay, for example, if I draw a vertical line here, okay, anywhere, okay, it's going to pass through only once. If I draw here, it will pass only once. It is passing just once. Okay, so if vertical line passes curve once, then it's a function. Okay, but if vertical line passes curve more than once, then it is not a function. Okay, see here you can see, if I if I draw a vertical line, it passes through this curve 2 times, right? It passes here and it passes here, means that this is not a function, this is a function. Now come here. If you draw any vertical line, it passes once. If you draw a vertical line, it passes once. This is your function. Now come to this. If you draw a vertical line, passes once, passes once, passes once. This is also a function. Okay, so always remember that if your vertical lines, it passes once, then the given curve is it is function. Okay, so this is important. Keep these things in your mind. All right, now few more things. Sometimes it may happen that you are just given with the function, okay, and then you are asked to find out the domain range, right? Let's say that here you are given with a function. Okay, you are given with a function, f is defined from a to b. Okay, and this function f is such that f of x is equal to y. Okay, so you have to find domain and range. Okay, now see here you are not given with sets, nothing, right? Just the function, and then they ask you to find the domain and range. So here you can do that, right? How? Now see here, your x represents what? Inputs, right? And what can be the input here? The input can be any real numbers, right? Real numbers. So your x, it's going to take all the real numbers, right? So I can say here x is going to take all the real values. So for all the real values, if you put here all the real value, any real value, you will get a real value corresponding to that. So your y is also going to be r, or in short, it is going to be f of r to r. Okay, so right, so here in this case, here domain, it's going to be the real numbers r. Okay, r, and your range, it's going to be r. Okay, now come to the next one. You are given with a function which says that your f of or function such that y is equal to x square. Okay, now you have to find out. Now see here you are just given with this thing, y equals to x square, and now what you need to find out, you have to find here domain and range. Yes, now here you need to use your mind, right? Because here you are not given with the values in set A, or you are not given with domain, you are not given with codomain, nothing is mentioned here, just only one liner, y equals to x square. This is the given function, and then you have to find out the domain and range. So if that's the case, now see here, if you look at x, right, x can take any value, right? X can take any value. For example, x can take negative values, yes. X can take any positive values, yes. X can take 0, yes. Okay, so it means that your x is going to be any real value, right? Any real value. Okay, so your domain, it's going to be any real number, right? But think about the range. Now if I put here plus 2, x is plus 2, y is going to be 4. And if I put minus 2, then y is going to be 4 2. right? So for all the negative real numbers that you are going to put here, you will get the positive values, and for 0 you will get the 0, right? So what does it mean? So it means that your range, it's going to be 0 to infinity, right? And your domain, it's going to be minus infinity to infinity, right? Why 0 to infinity? Because last time when we had this discussion on x square in basic calculus, okay, we have also mentioned there, if you take the square of any negative value, it's going to be the positive value. So the minimum value of x square, it's going to be 0, and the maximum, it can go to infinity. So here domain and range, you can find it this way. Okay, let's say number 3 here. If you have something like this, y is equal to 1 by x, and they ask you to find the domain and range. Okay, yes, this is a function. Why? Because for if you put any value of x, you will get unique value of y, right? You for one input, you will get one output. Okay, now see here, if you look at x, x can take any real value here, right? X can take x, or your domain, it can take any real value. But the problem here is that for 0, this is going to give us the problem. Why? Because if I put x equal to 0 here, then the output, it's going to be not defined. It means that here I can include the 0, because 1 by 0, it is not defined, right? So here my domain is going to be r minus, we have to exclude 0. And I have told you before, when you have to exclude particular values from the interval, you have to use this form, right? So x is going to be r minus 0, and what's going to be your y, your range. So your range, it's also going to be the same. Why? Because if you put any value of x, you will get values of y. Okay, but for 0, you won't get the value of y, so your range, it is going to be the same. Okay, and another way to write this is going to be minus infinity to infinity union 0 to infinity. Why? Because, sorry, minus infinity to 0. Why? Because we don't have to include 0. Okay, and same, this you can write minus infinity to 0 union 0 to infinity, means we are not including 0, but we are including everything except 0, right? Let's say that here. One more question we can do, number 4, y equal to x square minus 4. Okay, in this case, you have to find domain and you have to find the range. Okay, now see here, y equal to x square minus 4. Now x can take any value. X can be positive, x can be negative, x can be 0. So domain, it's going to be all real numbers, which means minus infinity to infinity, right? Now what about the range? Now see here, for negative values, it's going to be, for negative values, it's going to give us the positive values, right? And we are just adding minus 4 to it, right? So the value, it cannot be less than minus 4, right? So your range, it must go from minus 4 to infinity. Why? Because see here, this can be written as minus 4 plus x squared. So this function, the minimum range, the minimum output of this, the minimum value of this, it cannot be less than minus 4. Why? Because this can take the minimum value 0, so minimum value would be the minus 4, and then you will get the higher values. Okay, so that's why the range is 4 to infinity. So that's, see here, to, to find out domain and range, you have to think logically. You must know how this function will behave in that particular interval, or what could be the possible scenarios where it will get undefined. Understand? So you have to think um, from the holistic viewpoint, right? So you must make sure like you have a strong grasp on the basics. When we started calculus, I did lots of lectures on x square 1 by x, things like that. I'm using lots of things here. For example, how I wrote this, you can go there, you can find it out. I have made a special lecture on this. Okay, union, complement, right? Then about x square, behavior of 1 over x. Okay, so go through that, and I'm sure if you have gone through that, then this thing would be very easy. Okay, so today this is going to be the end of your session. So next time when we'll see each other, we are going to do a few more things on functions. So have a great time. Bye bye.